In Unit 1.3a, we will begin our exploration of elasticities. Elasticities measure the responsiveness of one variable to a change in another variable and is one of the most widely applied concepts in microeconomics. In other words, elasticity measures how much one factor changes in response to a change in a different factor. For example, if there's a significant change in price that may lead to a very small or very large change in quantity demanded depending on whether demand is inelastic or elastic. Let's explore further. For the business sector, elasticity informs the firm about the degree to which consumers will likely respond to raising or lowering prices. Elasticity enables producers to be aware of changes in the prices of other goods to expand their current market productions. Governments also use elasticities to determine which goods to place taxes on and whether or not to raise or lower income tax, and raising or lowering income tax stimulates or reduces overall household spending on goods and services in the product market. While there are 4 types of elasticities, such as price elasticity of supply, cross-price elasticities of demand, and income elasticities of demand, this unit will focus on price elasticity of demand. Price elasticity of demand, or PED, is a measure of the responsiveness of quantity demanded with respect to a change in the price of the good, as we demonstrated with the models earlier. PED answers the question of how much does the quantity demanded change when the price changes. PED is a coefficient which can be calculated using the following formula. I know the screen's a little messed up, so the formula is PED is equal to percent change in quantity demanded over percent change in price. The video's messed up, so we'll cover this more in class. For PED calculations, you must be able to calculate percent change. This is a very simple formula. Let me see if I can get my pen over here. There we go. All right, so let's see. There we go. So percent change is calculated as a new value minus old value over old value times 100. All right. Let's give a specific example. So let's say the quantity demanded has increased by 30,000 units from an original demand of 200,000, which is a change of 15%. All right. So this can be calculated by first figuring out what our new quantity is. So our new quantity is where we take the original 200,000 and then we add 30,000 to give us a new quantity of 230,000 units. So then we take the new unit, a new quantity of 230,000 minus the old quantity of 200,000 over the old quantity, and you will get 0.15. Multiply 0.15 times 100 and you will get 15%. How might this affect a change in price? All right, let's say the original price was $4.50 and the price increased by 50 cents. All right, let's say the price was originally $5, and it decreased by 50 cents. So our new price is $4.50. So we have our new price minus the old price over the old price, which is equal to negative 0.1, which then equals negative 10%. If we take both values, the 15% change in quantity demanded over the 15% change in over the negative 10% change in price, you get a PED coefficient of negative 1.5. This makes the demand inelastic at the new price, which means that that quantity demanded will not be very responsive to changes in price. It should be noted that as the numerator, or percent change in quantity demanded, is positive or increasing, the denominator, or percent change in price, is negative or declining. If the price of margarine rises by 10% and households respond by decreasing their quantity demanded by 20%, PED is equal to negative 2. However, if the price of butter falls by 10% and households respond by increasing their quantity demanded by 20%, PED is also equal to negative 2. Notice that every time the price elasticity of demand is a negative coefficient. This is due to the law of demand. However, in order to simplify matters, economists usually ignore the negative value that comes with the equation and simply express the coefficient in absolute value terms. If the price elasticity coefficient is less than 1, demand is said to be inelastic, because the given price change causes a relatively small change in quantity demanded. This means buyers are not very responsive to a change in price over a given price range. For example, when the price of a can of name brand hairspray is $2, quantity demanded might be 1,000 cans over the course of a month. When the price of the name brand hairspray falls to $1.50, so it declines by 50 cents, quantity demanded may rise to 1,200 units in that same month. The absolute value of this price elasticity of demand coefficient of name brand hairspray is therefore 0.636. You may want to verify this answer using the formula, but the coefficient is less than 1, which means consumers were not very responsive to the change in price, and that the demand of the name brand hairspray is therefore inelastic. If the price elasticity coefficient is greater than 1, demand is said to be elastic, because the given price change causes a relatively large change in quantity demanded. This means buyers are relatively responsive to a change in price over a given price range. For example, suppose consumers decrease the amount of specialty breads they buy at the grocery store by 20% when the price of these breads increases by 10%. The 10% increase in price results in a 20% decline in quantity demanded. 20% over 10% is equal to 2, indicating that the consumers are relatively responsive to a price change and that the demand for specialty breads is therefore elastic. If the price elasticity coefficient is equal to 1, demand is said to be unit elastic, because a given percentage change in price causes the quantity demanded to change by the same percentage. This means buyers respond to a given percentage price change by changing quantity demanded by the exact same amount in percentage terms. For example, if the quantity demanded of an output increases by 10%, then the price of the output the price of the output increases by 10%, then the percentage change in quantity demanded is equal to the percentage change in price. The price elasticity coefficient is equal to 1, therefore, and then demand is said to be unit elastic. Demand is perfectly inelastic when buyers are completely unresponsive to a price change, and the demand curve is drawn as a vertical line at a fixed quantity, as we will see soon. This means the quantity demanded does not change in response to a change in price. If demand is perfectly inelastic, then the elasticity of demand coefficient will equal 0, as we'll see again soon. Perfectly elastic demand is where the change in price will lead to an infinite change in quantity demanded, meaning just a small change in price means that quantity demanded could reach infinity or could reach absolute 0. And we'll see that'll make a lot more sense when we actually look at the models. So here, demand is perfectly inelastic when buyers are completely unresponsive to a price change, and the demand curve is drawn as a vertical line at a fixed quantity, as we see in this model. It might be helpful to notice that this demand curve looks something like the letter I, which is the first letter of the word inelastic, and so also we're going to use insulin as an example of an inelastic good. So for example, the demand for insulin is a good example of an inelastic good. Why? Because people who are diabetic depend on insulin to keep a healthy homeostasis between their glucose and their insulin levels, so they can stay healthy and stay active and these kinds of things. All right. So if there's an increase in supply or decrease in supply, which might lead to a change in price, it is not going to change quantity demanded, as people who are diabetic are going to still have to have insulin. It's a necessary good for them. So realistically, demand curves are not expected to be perfectly inelastic as price continues to rise beyond some point, but it is conceivable that a demand curve could be perfectly inelastic over a limited price range or time period. The vertical demand curve implies that consumers will continue to purchase the same amount, represented by Q in this case, regardless of the price of this product. For the consumers in this market, insulin is necessary, and there are no substitutes, so they will likely continue to purchase the same amount even if the price rises, at least to a point. When demand is perfectly inelastic, changes in supply will impact only equilibrium price because quantity demanded does not change. An increase in supply leads to a lower equilibrium price, but will have no impact on equilibrium quantity. A decrease in supply leads to a higher equilibrium price, but again, because the demand is perfectly inelastic, equilibrium quantity stays the same. This can be verified by sketching the changes in the supply on the graph, in the supply line on the, like in the model shown. Another possibility is that the demand curve is a horizontal line, as shown below, when the demand for the product is perfectly elastic. A horizontal demand curve is perfectly elastic as shown in this model. Notice that this diagram looks like the letter E, and the word elastic begins with the letter E. So it is easy to remember which is perfectly inelastic and which is perfectly elastic. When demand is perfectly elastic, consumers will buy any amount as long as the price is unchanged. In the model shown, demand is perfectly elastic at a price of $4. This may occur if there are perfect substitutes available for this product. If the firm raises the price even a little above $4, then the quantity of its product demanded drops to zero, because consumers will switch to the perfect substitute available from other firms at $4. The perfectly elastic demand function plays an important role in the model of perfect competition, which is represented in later chapters. In this model, product price is determined by market forces. A single firm is too small to alter market supply, so it cannot cause market prices to change. The firm, therefore, is a price taker. Since quantity demanded equals quantity supplied in market equilibrium, the firm is able to sell all of his output it cares to produce at the going market price. Therefore, there is no reason for a perfectly competitive firm to offer a lower price when the market is in equilibrium. When demand is perfectly inelastic, a shift in the supply curve will not change equilibrium price. An increase in the supply will lead to an increase in equilibrium quantity, and a decrease in supply will lead to a decrease in equilibrium quantity. It is unlikely that a market demand curve for any product would be perfectly elastic, but this kind of function is useful when studying the demand for a single firm's prediction under the assumption that the firm operating in a perfectly competitive market. Most demand curves slope downward to the right, and the price elasticity of demand will vary along the demand curve, even if the slope of the curve is constant. This is because slope measures the vertical change divided by the horizontal changes, but price elasticity of demand compares the horizontal changes relative to the vertical change. It's not just a measure of slope, it's a measure of percentage change between price and quantity. The model shown is linear, but using the midpoint formula, which we'll go over in class, to calculate the price elasticity of demand coefficient over different price ranges shows that elasticity decreases from moving down along the curve. If price falls from $19 to $18, for example, quantity demanded increases from 1 to 2 units. The percentage change in quantity demanded is 1 over 1 times 100, which equals 100%. And the percentage change in price is negative 1 over 19 times 100, which equals negative 5% approximately. The price elasticity of demand coefficient for this price range is therefore about 20%, which is greater than 1 when considering absolute value. Demand is elastic in this price range, therefore, which is a price greater than $5 on the graph below. If price falls from $2 to $1 and the quantity demand increases from 18 units to 19 units, the price elasticity of demand coefficient is then equal to 0.12, which is less than 1. Demand is then said to be inelastic in this price range, which is the price less than $5 on the model. The midpoint of this demand curve is at a price of $10 and a quantity of 10. The price elasticity of demand coefficient approaches 1 as price gets closer to $10. Calculating elasticity for a very small price range to $10 would give a price elasticity of demand coefficient equal to 1. So demand is unit elastic at the price, or when price is equal to $10. We will go over all these formulas, and we will go over how to calculate elasticities more in depth in class. So I hope you guys get just the basic conceptual foundation from this video. See you in class.